Chapter 9, Inheritance and Interfaces, Part 5. Steps to using inheritance. So let's consider an example. Suppose we have a savings account that earns interest, and the interest compounds monthly and is based on the minimum monthly balance. A checking account has no interest, gives you the first 3 withdrawals per month free, and charges $1 per transaction for each additional withdrawal. The program will manage a set of accounts of both types. It should be structured so that other account types can be added without affecting the main processing loop. So if we later decide that or find out we have money market accounts or Christmas savings accounts or other special types of accounts, maybe even loans, we can use the same main processing loop. The menu includes deposit, withdraw, month end, and quit. For deposits and withdrawals, query the account number and amount. Print the balance of the account after each transaction. In the month end command, accumulate the interest or clear the transaction counter depending on the type of bank account. Then print the balance for all accounts. So we want to link the classes as part of a hierarchy. Both savings account and checking account are bank accounts. So look at the UML diagram at the bottom. We're going to organize classes into inheritance, so we're going to use this UML diagram, and we're going to determine the common responsibilities. So what are the things that both types of accounts have in common? In other words, what would be useful to put in bank account? Write pseudocode for each task. So that means we'll write English-like statements to help us with our plan. So here's our pseudocode. For each user command, if it's deposit or withdraw, we're going to deposit or withdraw the amount from a specified account and print the balance. If it's month-end processing, for each account, we're going to call the month-end processing method and print the balance. This is very similar to what you may have already been doing in the lab assignment. So step 4, we're going to decide what methods are overridden in the subclasses. And for each subclass and each of the common responsibilities, we're going to decide whether the behavior can be inherited or whether it needs to be overridden. We're going to declare the public interface for each subclass. Typically, subclasses have responsibilities others than those in the superclass. List those as well as the methods that need to be overwritten. You will need to specify how the objects of the subclass should be constructed. We're going to identify the instance variables. So each of these behaviors will act on some data. What is that data? We're going to place the instance variables that are in common in the bank account class at the superclass, and then the other instance variables that are specific to each of the account types inside of those classes. Implement the constructors and the methods. That means write them. Implement is a fancy word for code. And then construct objects of different subclasses and process them. So step 8 is basically testing to make sure that our classes work. Let's talk about object. Object is the super duper class, as we've been calling it in class, and your book calls it the cosmic superclass, because every class in Java is implicitly derived from object. So every class in Java implicitly has object as its superclass. Some classes that we may have used: the string class, the scanner class, rectangle is another common one, part of the abstract windowing toolkit, and the question class that we've talked about in this chapter. So all of those have as their parent object. The toString method is part of object, and it will display an object as a string. So the job of the toString method is to display the object as a string. Without overriding the toString method, by default it displays what class it comes from and the location of that object, because that's all it's got. It doesn't have access to the instance fields in the subclasses, so the default toString method that's part of the object class will just print the name of the class and the address. So if we look at the rectangle class, which is part of java.awt, it has a toString method, and we can invoke the toString method directly by instantiating an object of type rectangle. And then if we call the object.toString, it returns java.awt.rectangle, so that's what class this is, x equals 5, y equals 10, width equals 20, height equals 30. X, y, width, and height are all instance fields inside of rectangle. So the toString method has been written to display each of those instance fields along with an equal sign and its current value. The toString method can be invoked implicitly, so we could just say the name of the object as shown in the second gray box. That's an implicit call to toString. The compiler can invoke the toString method because it knows that every object has a toString method. So it has the ability to call toString even when we don't explicitly call it or even when we don't override it inside our class. So it's handy to override the toString method because if we rely on the default, again, we're just going to get the address. So look inside that first gray box and see the blue text. The comment sets S to something like bank account at D24606BF, and that would stand for an address. Not very helpful. So we do want to override that toString method, and we'll do it in the bank account class as follows. Public string toString. So the toString method should always be called toString. It should always take no arguments, and it should always return a string. That will override the toString method in the base class, in this object class. And then if we provide some functionality, in this case they say bank account is the name of the class, balance equals, and then concatenates that together with the current value of balance. That can be helpful. As you've seen in class, you can override it to be anything you want. Like this is a savings account with exclamation points. Not an incredibly useful, but certainly it shows you that you can override toString to return any string you want. It should return the contents of the object as a string. The equals method compares two objects, and there is an equals method as part of object, but we can override it to be specific to whatever object types we are using, so we can compare the instance fields inside the object. With the dot equals method, its intent is not to say whether one object is an alias for another, but to determine if they have the same contents. In this example with stamp 1 and stamp 2, they do not have the same contents. The colors are different and the values are different. So using dot equals is different from using the relational operator equals equals, the equal to operator, because using dot equals is a method and you can override that to compare each individual instance field. Using the relational operator equal equal just compares the address stored in the reference. So it's not saying do they have the same contents, it's saying do they occupy the same location? Are they aliases for the same object? Sometimes you want to know that, but typically people want to override the equals method. So here's an example from class stamp that has a color, which is a string, and a value, which is an int. And if we override the equals method, we first, inside the second gray box there, public boolean equals object. So when we supply object as our parameter, that means that we are overriding the superclass method. And note that a superclass reference can always be satisfied by a subclass reference because the subclass is a superclass, not the other way around. So we can pass a stamp reference to this equals method, but we will need to downcast it so that we can get access to those instance fields. So that first line of code, stamp other equals stamp other object, we are downcasting other object to an object of type stamp, and then we are return color dot equals other dot color. That's calling the equals method inside the color class, inside the string class, and value equals other dot value. That's using the relational operator equal because value is an int.